We need to review for the quiz, and we need to finish talking about vertical shifts when you're doing sine and cosine graphs, okay? So quiz review this semester, I said, is pretty much like you ask me and I help you. Before you sit down, Kristen, will you flip the switch closest to the call button? Anybody questions? Yes. Okay, fine. Exact values. Can you tell me where you're looking on there? Like special right triangles here, or? These? Okay. So these are using the unit circle, which I don't think I put a unit circle on my slides here. Let me see if I have one real quick. Feel like I do. My little handy dandy list of extra slides. I think they're alphabetical. Where's unit circle? Using unit circle? That'll work. Okay. So let me save this quick. The first one says go to 7 pi over 6 and find the sine, which is just the y value, right? So 7 pi over 6 is here. The y value is -1/2. We write down -1/2. Yeah, but some of them are trickier. Like number 20, cotangent -5 pi over 6. So 5 pi over 6 is 150 this way. -5 pi over 6 would be down here where we just were, right? And then it said cotangent. What's cotangent, guys? X over y. So it's going to be negative square root of 3 over -1, because remember the denominators are going to divide out. So negative square root of 3 over -1 would just be positive square root of 3. We good? Like this one isn't on your unit circle until you do what? Yeah, so like if I add 360 a couple times, where am I at? I could even add it 3 times, I think, to get a positive number. 240 if I add it 3 times? No? Okay, so positive 240 is the same place. So if I'm at positive 240 right here, here's my ordered pair down here. So it wanted the sine. So it's just negative square root of 3 over 2. How about like cosecant? What's the cosecant at negative pi over 4? The ordered pair at negative pi over 4 looks like this, right? Okay, what's the cosecant? It's the reciprocal of sine, which is this one, so you were almost right. When you flip that over, you do get root 2, because you do some of this fun. Get 2 root 2 over 2, which reduces to root 2. But what was the sign on it? Yeah, so it should be negative root 2. Because it's y value, right? Am I wrong? On the pi over 4, yes. We're in quadrant 4, okay? Cosecant at 0. The ordered pair is right 1 and up 0. So the cosecant is the flip of which one? But cosecant is reciprocal, right? So it's 1 over 0 is undefined. What's 0? The sign is 0, right? But its reciprocal is undefined. More? Are we good? What else? For more practice on this, there was worksheet 8 and page 251. Yes, Tara. This stuff right here, am I in the right spot? Okay. So this is the 30, 60, 90, 45, 45, 90 stuff that we did in practice a ton. That's why I put some on this sheet for you. I'm just going to do all of them real quick. From the 60, okay, so the short leg is down here. Okay, let's just write the patterns over here. If you have the short leg on a 30, 60, 90, it's x, and across from the 60 is x square roots of 3, and the hypotenuse is 2x. If you have, whoa, what is that? If you have a 45, 45, 90, it's x, x, and x square roots of 2. That's if you have 45, 45, 90. Okay, so this one, this is the short leg. So we need to take the short leg times the square root of 3 right here, which would be square root of 6 times square root of 3, which is, anybody? I thought so too for a minute, but then you're multiplying. So it's square root of 18, which is 9 times 2. So you get 3 square roots of 2. That's weird because not used to having a square root of 2 on a 30, 60, 90. And then you double it to get the, no. You double the short leg to get the hypotenuse. So it's 2 square roots of 6. That's an icky one. All right. And number 4, this is supposed to be the leg times the square root of 2. So you have to divide off square root of 2. 6 over square root of 2 is what? 6 square roots of 2 over 2, or 3 square roots of 2 on both of those, okay? Down here, this pattern, so did you figure this out yet? No? The hypotenuse on a 45, 45, 90 is just leg times the square root of 2. So if this is leg times the square root of 2, the legs are each just 7 and 7, okay? And what about a 30, 60, 90, guys? The hypotenuse is? Yeah, whoops, 2 times a short leg. I don't even know what that's supposed to say. S and L. Okay. So the short leg, oh my goodness. Just give up, half hour. Short leg. Short leg equals 4, which would go here. And then the long leg would be 4 square roots of 3. Yes, no? You did have a whole extra worksheet on this, right? Do you remember I gave you a warm-up one day on this? Okay, good. I was like, you should need some more practice. Okay, what else? Mackenzie? This one? Okay. So on all of these, there's some that actually say find the quadrant on the quiz, and then some that say find the reference angle. So I'm going to do both real quick. Let's do this one that's drawn first. If this is negative 705, like if I add 720 to that, I get 15 degrees. So that's actually the angle with the x-axis, right? So this would be quadrant 1 and 15 degrees. All right. Do you want me to do this in degrees or radians? Eventually your answer has to be in radians, Mackenzie, but how would you maybe think about this? You always do degrees? Okay. So if we change this to degrees, so we multiply by 180 over pi, it's going to be 15 times 45. Okay. And then we'd maybe subtract 360 so we could figure out where we were. Do we get 315? That's what I was thinking it was going to wind up at. Is that right? okay? So what is the reference angle at 315? First of all, what quadrant are we in? Because some of them ask that. Okay, this is quadrant 4. And I don't care if you use Roman numerals or not. You can just write 4. And the reference angle is what then? Okay, if you're here, it's back to here is 45 degrees, which then you need to tell me the answer is radians. So it would be pi over 4. Yes. No. No. Like this one, I would add 360. Just because you're just getting another name for it. And this isn't helpful to me necessarily. It certainly could be. If I want negative 167, my reference angle is just the rest of the way to here, right? So actually, if I just added 180, I'd be done. Is it 13, guys? So the reference angle is 13 degrees, and it was in quadrant 3. 1, 2, 3, right? Yes.
Like number 34, when it says less than 0, that just quadrant.
Yes. This is probably the section I'm most worried about on the quiz, so let's do a couple of these, at least set them up, okay? So we can figure out what quadrant we're in. This is the very end of the purple sheet. Says find the exact value of the 5 remaining trig functions. Well, we don't have to necessarily do that, but let's try to figure out from the clues what our triangle looks like and what quadrant it's in. So the cosecant is 2, where the sine is, okay, guys, you got to know your signs. What does this mean? Greater than 0, so the sine is positive, right? And the cosine is less than 0, means the cosine is negative. What quadrant is that true? So if I know I'm in quadrant 2, what am I going to label on this picture? Yeah, cosecant is the flip of sine. So the sine would be 1/2 if we wanted to write that down. But the sine is opposite over hypotenuse, or the cosecant is hypotenuse over opposite. So what do we have to do to find the missing piece? Yes, leg squared plus missing leg squared equals hypotenuse, squared. So you square this and you get 4, square this and you get 1, you subtract, and you get 3. The leg is square root of 3, but because where it is, it's actually what? Negative square root of 3. So now you should be able to find all 6 functions. Do you need me to go through them? Anybody? No? Good. Okay. So in that quadrant, which should be negative? What 2 functions should be negative? Actually, yes, there should be 4 negative, right? I lied. Cosine and secant and tangent and cotangent. Yeah. All students take calculus, right? This is only sine and cosecant should be positive. Those should be the 2 positive. The rest should be negative. All right, let's set up 35 for practice. What is this saying right here? Yeah, the sine is negative, and then it's going to help us draw the triangle. And it also says back here the cosine is, which is positive. So where is the sine negative, but the cosine is positive? All students take calculus right over here, right? So sine is opposite over hypotenuse. And because it went down and because it said it was negative, we good? So what would we get right here? Yep. Square root of 24, or 4 times 6, 2 squares is 6. And the sine? positive because we're going to the right in quadrant 4. All right. Do you want me to do some of the functions? Like, what would cosine be right there? 2 root 6 over 5. So secant would be a disgusting 5 over 2 root 6 multiplied by root 6. You'd get 5 roots of 6 over 12. All right. Want me to set up 36 still? What is this saying? Cosine is, right there it says negative, right? And this means this is less than 0, so the sign is also negative. So what quadrant are we in? And cosine is x over r. So this is negative 12 and 13. Anybody know that particular right triangle? Got one number, right? I don't think so. Yeah, 169 minus 144 is 25. This is just 5, right? Good. Oh, it's not 5. It's negative because we went down. So the only thing that should be positive in that quadrant are tangent and cotangent, yes? Any questions? Honestly, I don't think on the quiz that I asked you all 6 functions. I just said, tell me what quadrant it's in, draw it, and then give me, I asked for 2 or 1 even, I don't remember, okay? Anything else on the review or on the homework? Nobody asked angular linear velocity, yes. Tara. This is a homework question for a number 36. Great. What does it look like? I don't have the right slide, apparently. Is it like this kind? Where it gives you words like that? Okay. So what does it say? Find CSC. Okay, cosecant, good. Okay. These are just right triangle. There's no like quadrant stuff yet. So therefore I draw quadrants. That's not helpful. If you just have a triangle, secant is the flip of cosine, right? So this means the cosine is 4/13 or adjacent over hypotenuse. Cosecant is the flip of sine, so I need this side over here. So if I do Pythagorean theorem, 169 minus 16, 154 to feet 3. Yeah, that, which is, does 3 actually goes into that? Does 9 go into that? So we get 3 square roots of 17. That's lovely. And then it wanted actually the cosecant, you said, which would be the flip of sine. So it would be hypotenuse over opposites. Lovely. 13 over 3 square roots of 17. 13 square roots of 17 over 51. Is that not what the answer key had or something? Or okay. 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 Gotcha. It was ugly. Yes. I can see where you would get that answer and be thinking you did it wrong. Something else? Nobody needs angular linear velocity, anything? Okay. Do you want me to at least do the one that's on the review? Which one's this one? No, we did those.
I have a no.
These? Okay. These are, you could actually use your unit circle, but you didn't hear that from me, okay? You could find the secant of 60 or the cotangent of 60 using your unit circle and you'd get the same answer. But you're supposed to use the 30, 60, 90 that's here. So half of this number goes on the short leg, and then the short leg times the square root of 3 goes here. So secant from 60 up here, secant is the flip of cosine. So it's adjacent over hypotenuse, or in this case, hypotenuse over adjacent. So you'd get 6 over 3 or 2. Cotangent would be adjacent over opposite, because tangent is opposite over adjacent. So cotangent would be 3 over 3 square roots of 3, which would reduce to 1 over the square root of 3, which would be square root of 3 over 3. Does that follow, or did I do too much in my head? Okay, this would be 3 over 3 square roots of 3, which is 1 over square root of 3, which rationalizes to that. 45, 45, 90 would be 5, 5, and 5 square roots of 2. So the sign would be 5 over 5 square roots of 2, or just 1 over square root of 2, or square root of 2 over 2 if you just used your unit circle, right? And the secant is the flip of that, which is, this is actually the flip of the cosine, but the cosine is the same on a 45, 45, 90. All right, I'm about to be done reviewing unless somebody still has a question. I thought maybe you wanted me to do this one. Okay. If it's turning at 1750 revolutions per minute, what do we need? The radius of 4. We need radians, yes. None of the formulas use revolutions or degrees. So 1 revolution is 2 pi radians. Okay, then what? We want feet per minute. What's the formula for linear velocity that we've used the most? Angular velocity times radius. Does that look familiar? So the radius was 4 inches. Now the radians will go away and we have inches per minute. How do I get it to feet per minute? We need inches to cancel and feet on the top. So 1 foot is 12 inches, so we're actually dividing by 12. I have to write it out because I have to think about it too. So the inches divide, and now we're left with feet and minutes. So we have 1750 times 2 pi, go ahead and put the pi in, times 4, and then divided by 12. Anybody else getting that number? I'm going to trust Kayvon. Okay. He's got your back. Arc length and area of is that not what you're getting, Miranda? Or Marissa, sorry. Now what you got? Did you put the pi in? Did he put the pi in? Did you divide by the 12, Marissa? Okay, no worries. Just double checking that everybody's getting it. All right, arc length and area of a sector, we're good? Okay, just formulas, but you got to be in radians. I think one of them they give you the radians and one of them you have to change it to radians. All right, I'm moving on to worksheet 10. We talked about the basic shape of the sine graph last week. which started at the midline and went up and down. Remember that? And the cosine graph, which started at the maximum and then went up and down. Okay, that's what we're going to need today, is that idea. We also looked at this slide. By the way, your notes are typed wrong, I think. I don't know if I fixed this on your notes. If we factor out B, then the phase shift is the opposite of C instead of the opposite of C over B. This is maybe at the top. You don't have this exactly? Okay, then let's fix it on this spot. You have this, right? Maybe. Do you have this right here? Phase shift, opposite of C, if it's factored. Is it fixed on yours? Oh, okay. It's not, we're not doing that today anyway. We're doing vertical shift, okay? The vertical shift is going to be this number that's added or subtracted onto the back, okay? And the midline is going to be whatever that is. And then if you were given a graph, you would find it this way, but we're just doing shifting it today. So it'll go above and below that midline, okay, whatever the amplitude is. When we get to phase shifts, you're going to have to do this, but that's not necessarily going to be today. So we did these on Friday. Let's talk about number 4. What 2 things have changed from the basic sine graph, guys? Okay, what is this doing? The amplitude equals 2, which is really a stretch, right? Okay. Normally it would mean the maxes and mins were going to be at 2 and -2, but that's not going to happen. Why? Yes, this is a vertical shift of up 3. Now, I really, really, really wish they would put those parentheses there so that it was clearer. Okay, but if there's no parentheses, it's just around the theta. So it is a vertical shift. So I know some teachers, and I'm okay with it, just have you rename this as the midline, right? I'm going to actually go ahead and sketch it with a vertical shift up 3. Oh man, let me try that over again. So crooked. Well, yeah, that's much better. 1, 2, 3, there's my midline. And, okay, so how far above and below my midline of y equals 3, which it will ask sometimes what the midline is. How far above and below that midline am I going? 2, because the amplitude is 2, okay? So my maxes will be at 5, and my mins will be at 1, okay? Now, if you just renamed the x-axis y equals 3, that's fine. Just be really careful that you write your ordered pairs correctly. All right, where am I going to start? Because it's a sine graph, I'm going to start at the midline, right? So in this case, it's 3. If you renamed it, I understand why you would say 0. So start at the midline, okay? And it's going to do what first? Okay, so my little quarter circle, quarter circle. All right. So on a quiz, it might say this: A equals B equals amplitude equals period equals vertical shift equals midline equals. All right. You would say A is 2, so the amplitude is 2. B, there is no B, it's just 1, right, in here. So what is the period of this function? What is the period of every sine or cosine unless there's a B in there? It's just 2 pi. The vertical shift was up 3, so the midline is y equals 3. I was trying to practice how it'll look on a quiz. And there is no phase shift. Yes.
Why do you write A?
Because the quiz might have both blanks.
Oh,
Because I just need you to tell me that. For example, Kayvon, if this had been a -2, you would say A is -2, but the amplitude would still be +2, because amplitude is always positive. Okay. Yes, Tristan.
is
No. Good question. Not on the quiz tomorrow. All right, so can anybody tell me the ordered pairs that I'm looking for? It finished by 2 pi. So if we divide that by 4, what are we counting by? 2 pi divided by 4 is pi over 2. So this is going to be 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and then 4 pi over 2. All right, so the first ordered pair right here, anybody? Over 0 up 3. This maximum up here is pi over 2, 5. Midline is at pi 3. Minimum is at 3 pi over 2, 1. And back at the midline at 2 pi 3. I think in the quiz I wrote the ordered pairs off on the left or something, just so that you didn't have to, I don't have to try to read them all scrunched on your graph. But any questions? Yes.
right.
Yeah, you can draw it on the axis, but your ordered pairs are what I'm looking at. So be very careful you write the ordered pairs correctly. Yeah, and what he's asking is, can we just rename this as y equals 3? That's fine. So your graph would look just a little bit, it would look the same, but it wouldn't have this line down here. This would just be your y equals 3. All right. Do you want me to do one that way, guys? Where I rename the y-axis, or it doesn't matter? Huh? This can be rewritten cosine of what? What's theta over 2 mean?
1.
Okay. So what's A?
1.
Yeah, there isn't one out here. It's just a 1. So that means the amplitude is just going to be 1. Okay. What's B in here?
1/2.
B is 1/2, which makes the period, remember it's a reciprocal value, so it's 2 pi divided by 1/2, or 2 pi times 2 over 1, which is 4 pi. Good job. There is no phase shift, but there is a vertical shift of what? Yeah, down 4. So the midline is at, yes, y equals -4 is actually the equation. All right, let's see how badly Hofbauer can draw this one. 1, 2, 3, 4, and it's only going 1 above and below that. Okay. So there's my midline at y equals -4. 1 above and below would be -3 and -5, right? What's the other thing I need to be aware of? That the shape of a cosine graph is what? Yeah, it starts at the maximum and goes down. So I'm going to start here. Quarter circle, something like this. Not well drawn at all. I don't know if that's any better or not. Looks a little more symmetric, but we need some x values. We have y values here. What is this x value where this ends? Yeah, we said the period was 4 pi. So if we take that and divide by 4 to get quarter points, what are we counting by? So if we split this in half, we have 2 pi at the min and 1 pi where it's crossing the midline and 3 pi where it's crossing the midline here. Ordered pairs, anybody? I'll just list them up here this time. 0, -3 was that one. This one is pi -4, it's at the midline. 2 pi -5, good job. 3 pi back at the midline. And 4 pi at the max, which was -3. Okay, that's these ordered pairs down here. I just wrote them up there. Is there more practice? One more? Yeah, one more, and then we're gonna maybe practice a phase shift question. We'll see what we have time for. Okay, what's going on this time? All right, so the actual A is -3, but what does the amplitude mean? 3, okay? The negative is going to do what to our shape? So it's a sine graph, which would normally start at the midline and go up, but this one is going to do what? Midline, go down. It's going to be like this. All right. What's the B value? Nope. Well, yeah, that's what I was thinking too. No, yes. It is 1. There is no period change, so the period is what? 5. There is no phase shift. Okay. But the vertical shift is what? Up 1. So the midline is y equals 1. All right, so if I draw this, if y equals 1 is the midline, how far above and below that does it go?
4.
Yeah, 3 units. So this would be up to 4. And if we go 3 units down, we'll be at -2. I usually draw these just as boundaries for my own information, but you don't have to. All right, then we said it's going to start at the midline and go down, right? Because of the negative. So there's the midline. Goes down, back to the midline, maximum, back to the midline. All right, what about our x values? The period was just 2 pi. So halfway would be, now be careful, that's not where this is, it's where this ordered pair is, right? And where this ordered pair is would be, we divide that by 4, we're going to count by pi over 2. So this is a pi over 2, 2 pi over 2, 3 pi over 2. Okay. So the ordered pairs, anybody? 0 what? 0, 1. Pi over 2. Pi. 1, 3 pi over 2. Maximum. And 2 pi midline again. Anybody else have a question before we try to do one phase shift? All right. Yeah, phase shift actually is not on worksheet 11, I don't think. And your homework tonight is to finish the assignment on worksheet 11. Oh, I know what we need to do rather than do a phase shift. Let me go. Worksheet 11 has some questions about identifying. So you have to be able to identify the phase shift. So let's talk through a couple of these without actually graphing today. That's a better plan. Skipping that one today. Skipping that one. Okay, what's the phase shift on this one, guys? This is on the back of worksheet 10, but I'm not going to actually graph it. But what's the phase shift? Okay. Is it going to be left or right if it says minus and it's in a parenthesis?
Right.
Yes, this is a phase shift right pi over 3. Whoa, no, just kidding. I don't know what you're doing. All right. I don't know that you have this example, but this is off of what worksheet 11 has some questions like. The issue is this 6 is not factored out, okay? When you do this, just help me real fast. When it said 2x plus 8, how did you factor that? You took out a 2 and it left. And what was the relationship when you got this? You divided out the 2, right? Everybody okay? We divided out the 2 because we'd multiply it back in. So if I want to get rid of this 6 right here and put it on the outside, I'm dividing by 6. So 6 would be theta. How do I do that divided by 6? It would become what?
11.
Dividing by 6 is the same as multiplying by? Okay, so we'd have minus 11 pi over 36. Okay, you don't have this question. You can write it down somewhere if you want, but it's like worksheet 11. Okay, now that I've factored it out, tell me the amplitude. Okay, the period, 2 pi divided by b, which is 6, so pi over 3. The vertical shift, yes, down 4. And then the phase shift. If you did opposite of C over B like you were probably taught in trig, you'd still get the same thing we're going to get, but because we factored it, you can clearly see that it's to the right 11 pi over 6 because the sign is the opposite of the direction, right? 36. Just kidding. Sorry, thanks for catching me. All right. So let's do 5 and 6 at the bottom and then we'll be done for the day. Do you have these two at the very bottom of 10b? Okay. So let's stick these numbers into the equation. It says write a sine function with an amplitude of 2, a period of 4, a phase shift of 1/2, and a vertical shift of 4. Well, which one's going to give us trouble?
The phase shift.
Is it? Okay, so I'm doing number 5. I'm going to have y equals, there's a sign. Where else do you know? Good job. Amplitude of 2 is out front.
And then you
This plus 4 is at the back. Okay. So we did that and we did this. No. If the period is 4, we have to do some work. Remember, that means 2 pi divided by some b gave us 4. Or 2 pi, you can just flip-flop those. 2 pi over 4 equals b. So it's pi over 2. Because now, if you told me, well, 2 pi divided by some weird b, Miss Hofbauer, that would be 2 pi times 2 over pi, which would give me 4, which would make the period 4, right? Okay. And then the phase shift goes inside here, so it's just, I'm going with minus 1/2. Yeah, I think they want it to go to the right, so we're going to do minus 1/2. That's not clear. I would have written words. All right. I think we're better on 6. Can anybody do 6 real fast? Does it have a crazy period? No, so we're going to assume it's the same. 1.2 sine theta minus 3 pi over 2 plus 1. All right, guys, so quiz tomorrow, and your homework is to finish these problems on worksheet 11, okay? Abruzzo is not posting a quiz review for her class. I didn't officially post a quiz review, but I did record the whole lesson. So we did a little bit of quiz review at the beginning, okay? Yep.